ബേസിക് കോൺസെപ്റ്റ്സ് ആയിട്ടുള്ള ഡയറക്ഷൻ കൊസൈൻസും ഡയറക്ഷൻ റേഷ്യോസും എന്താണെന്നാണ് നമ്മൾ ആദ്യം പറയാൻ പോകുന്നത്. ഡയറക്ഷൻ കൊസൈൻസ് നമ്മൾ DCs എന്ന് പറയും, ആൻഡ് ഡയറക്ഷൻ റേഷ്യോസ് DRs. ഡയറക്ഷൻ കൊസൈൻസ് DCs ആൻഡ് ഡയറക്ഷൻ റേഷ്യോസ് DRs. ഓക്കെ, ഡയറക്ഷൻ കൊസൈൻസ് എന്താണെന്ന് ആദ്യം പറയാം. അതായത് if alpha, beta and gamma are the angles made by a line with the positive direction of x, y and z axis, then the cosine of these angles alpha, beta, gamma, that means cos alpha, cos beta and cos gamma, are called the direction cosines of the line. Okay, which they are denoted by L, M and N. And this L, M, N, the direction cosines, satisfy the property that L square plus M square plus N square is equal to 1. Okay, now what are DRs, direction ratios? They are simply three numbers proportional to this L, M, N. Three numbers A, B, C which are proportional to L, M, N are called direction ratios. That means L by A is equal to M by B is equal to N by C. Okay, then what is the relation between this DCs L, M, N and DRs A, B, C? We can find DCs L, M and N using the equation L is equal to A by root of A square plus B square plus C square, and M is equal to B by root of A square plus B square plus C square, N is equal to C by root of A square plus B square plus C square. Okay, so now the one more formula is how to find the direction this ABC if we are known with 2 points on the line. Okay, so we are known with 2 points, let P x1 y1 z1 and Q x2 y2 z2 be 2 points on the given line. Then using that you can find direction ratios and thereby direction cosines using this formula. So direction ratios are given by the difference between the coordinates. A is x2 minus x1, B is y2 minus y1 and C is z2 minus z1. So direction ratios are known, means direction cosines are also known. So these are the basic concepts, how to find direction cosines and direction ratios, DCs and DRs. Now let us go to what are the three basic concepts in three-dimensional geometry about a straight line. So we have the first one is how to find the equation of a straight line. There are two forms for the equation of a straight line. That means suppose we have a straight line in space. Suppose this is the line in space. This is the line L. This is your x-axis, x, y and z axis. So we have to find the equation of this straight line. So for that we are given a point A on the line. This is a point A, a given point, and whose position vector is vector A. That means OA is equal to vector A. This point having position vector A, and we are also given a vector which is parallel to this line. Maybe here is a vector B, this vector B which is parallel to L. So we are given two quantities. What are the two given quantities? We are given with a point A on the line having position vector A. So we are given a point having position vector A, and we are also given a vector parallel to the line L, a vector B parallel to the required line L. Okay, so we wanted to find the equation of this line. So the equation of this line and this vector, they are parallel to each other. So the equation of this straight line when these two quantities are given is given by r is equal to vector A plus lambda times vector B, where r is the position vector of any point. Let P be any point on the line. So here is a point P whose position vector is vector r. Then r is equal to A plus lambda B. Lambda is a constant. This is called the vector equation of the line or vector form of the equation of the line. So in order to find the vector equation of the line, we need only two quantities. What are the two quantities? We should know what a point A on the line whose position vector is A, and we need to know a vector B parallel to the line. So A and B are the quantities we should know to write the vector equation of the line. Okay, then we can also find this equation in the Cartesian form. That means instead of the position vector A, you will be given the coordinates of the point A. That means let A be the point. Coordinates are x1, y1, z1. Now instead of vector B, you will be given the direction ratios of our line, or vector B is AI plus BJ. ABC are the direction ratios of our line or of the parallel vector, you can say. So ABC are the direction ratios, then vector B is AI plus BJ plus GK. So if these two quantities are known, we can write the same equation can be written in terms of in Cartesian format as x minus x1 by A is equal to y minus y1 by B is equal to z minus z1 by C. So this is called the Cartesian form of the straight line. So these two are the same equation. One is expressed in terms of vectors, one in terms of coordinates, Cartesian form. So this is called the Cartesian form of the line or Cartesian equation of the line, Cartesian form. Okay, so you will be asked to find the vector form as well as the Cartesian form of the line. So in order to write the Cartesian equation of the line, we should know the coordinates x1, y1, z1, and we should know the direction ratios of the line, drs. Drs are ABC. Drs and the point is known, we can write the equation, standard equation of the straight line. This is the first concept you have. Then second one is, what is the angle between two lines? Angle between two lines. So first one is equation of the line, and equation of the line we have written that there are two forms. First one is vector form and then next one is Cartesian form. Now we have angle between two lines. You know, in R is equal to A plus lambda B, B is a vector parallel to the line. So if you find the angle between two lines L1 and L2, if theta is the angle between them, this theta is the same as the angle between the corresponding parallel vectors. So, and in vector algebra, we know how to find the angle between two vectors. So, suppose the two lines are R is equal to A1 plus lambda B1. B1 is the vector parallel to the line L1, and the second line equation is R is equal to A2 plus some other constant mu into B2. So these B1 and B2 are the two vectors parallel to these two lines. So angle between L1 and L2 is angle between the two vectors, and from vector algebra we know that angle between two vectors is given by cos theta is equal to B1 dot B2 by magnitude of B1 into magnitude of B2. The same formula can be used to find the angle between two lines, isn't it? Okay, then we can also check whether two lines are perpendicular or parallel using the same concepts from vector algebra. That means if these two lines are parallel, we know cos theta, cos 90, 0. L1 is parallel to L2 means B1 dot B2 is equal to 0. Or you can say if the first line is having direction ratios A1, B1, C1 and the direction ratios of the second line are A2, B2 and C2, then we can write B1 dot B2 is equal to 0 is the same as A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So this is the condition for two lines to be parallel. And if the two lines, I'm sorry, two lines to be perpendicular. So the angle between two lines is cos theta is equal to B1 dot B2 by magnitude of B1 into magnitude of B2. Now, if these two lines are perpendicular, theta is equal to 90 degree. That means B1 dot B2 is equal to 0. That is, or A1 A2 plus B1 B2 plus C1 C2 equal to 0, where A1 B1 C1, A2 B2 C2 are the direction ratios of the two lines. Now, if the two lines are parallel, similar manner, you can say that in A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So, these are the conditions for two lines to be perpendicular and two lines to be parallel. Okay. Now, the third concept we have to learn is about how to find the shortest distance between two skew lines. What are the skew lines? Are two lines in space which are neither parallel nor intersecting. So, how to find the shortest distance SB between two skew lines? Shortest distance between two skew lines. So these the lines are these two lines, R1 is equal to A1 plus lambda B1, A2 plus mu B2. Then the shortest distance D between these two lines is given by the formula A2 minus A1 dot B1 cross B2 divided by magnitude of B1 cross B2, which is a scalar. If you're getting it as a negative number, you have to take the modulus of all the positive values since distance is positive. Okay. Now, we have another formula how to find the distance between two parallel lines. Distance between two parallel lines or distance between two parallel lines. So, in that case, the two equations are given by R is equal to A1 plus lambda B and R is equal to A2 plus mu B, because the two lines are parallel. We have their direction ratios are proportional. So there is no B1 and B2 since the two lines are parallel, that is the same B. So in that case, the distance between the two parallel lines is given by D is equal to, we have A2 minus A1 cross B by magnitude of B. And we will take the magnitude of that because it's a cross product. A2 minus A1 cross B by magnitude of B. So these are the only three concepts you have to learn in three-dimensional geometry. First is how to find the equation of the line, vector and as well as Cartesian form. Then we have how to find the angle between two lines. Angle between two lines is the same as angle between the vectors B1 and B2. So accordingly you have the two conditions. If the two lines are perpendicular, this is A1 A2 plus B1 B2 plus C1 C2 0, parallel A1 by A2 ratios are equal. And finally, you have the formula to find the shortest distance between two skew lines. This is the formula you have to remember. And distance between two parallel lines, A2 minus A1 cross B. Here it is dot B1 cross B2. Here it is cross B by magnitude of B. So its magnitude should be taken. So only three concepts in three-dimensional geometry.